Hey, everybody. Welcome to the Data Science Deployed podcast. I'm Ben.
I'm Jillian.
And I'm Donny.
Today, we are going to chat about Pangeo.
Very
Yeah,
cool.
so Pangeo is it's I think like an earth science, climatology, geology kind of in that realm. It's a community of scientists who all got together and I think previously at least decided to use Jupyter Hub as kind of a base for deployment. And a lot of really cool projects have come out of that, and I just think the ecosystem is really interesting, and I run around stealing things from it like all the time. And that and that they've also done a really good job with some of their other aspects too, like community building. They really go all the way from kind of like the low end infrastructure on Kubernetes to the to like the higher end, really like manuals for scientists kind of idea. They have like website, they have some forums, I think maybe a Discord forum, and they also have a lot of pre-configured Jupyter Hub instances that have, like Dask Gateway, and a lot of data science kind of packages and things all sort of, bundled into one kind of meta package. So I guess so I'm just wondering a lot, like, what are your guys' thoughts on, having a development infrastructure set up like this? Is it good? Is it bad? Are you guys seeing this when you're out and about working, working with clients or just out there talking to people?
Well, one thing I'm familiar with in terms of a bundle, at least for introduction and training, I do a lot of work with the Carpentries Foundation, software carpentry, data carpentry, and we'll have workshops to teach computer skills to scientists, and we'll definitely like the Anaconda distribution of Python, which is essentially something that includes a lot of packages. So you kind of it already has a lot of typical packages that you'll need, like NumPy and Matplotlib and things, and that's often very nice because you people don't have to learn necessarily how to pip install or conda install right away to sort of get bare bones with stuff that they kind of perceive should be in their standard library but isn't in the Python standard library. Um, uh, However, when it comes to deploying a lot, I often prefer, in that case, for that specific platform, to use like Miniconda or something to start with something bare bones, a certain Python version, and all my dependencies. So it's interesting, to sort of get people started. I think it's really nice to kind of have everything in there. But then I think when I start to develop things and want to pin dependencies and make sure to have things reproducible and see like why something isn't compatible with this or that, I kind of want a little bit more fine-grained control over my dependencies. But definitely when I'm starting out, it's nice to just kind of have like a bunch of stuff. And I feel like that's really nice, especially if you're a domain expert. Like a lot of these workshops are for scientists, and so it's like I don't really care about all these other things. I just want sort of a big nice package, and I see Pangeo as sort of in the family of that sort of thing. Like here are a bunch of things you can start out with. It's sort of like walking into a restaurant and having a menu and being able to select from it, and just knowing that it's all good, as opposed to like, well, I could eat anything technically. So I kind of like that. It sort of simplifies decision making for people at the beginning of their journey, and if they just want to get a particular thing done. Um, I found that to be successful, at least in that pedagogical context, very successful.
I completely agree with you. I think I even categorize it very specifically into two distinct workflows. So I think I've got like a scratch workflow if I'm trying to develop an algorithm or make a visualization or understand how a little piece of code works. I want the kitchen sink. I want Jupyter. I want Anaconda. I want everything. And I don't want to think about installing dependencies and pulling my environment together. On the other end, if I'm trying to build a system that's going to run in production, I actually do care about each dependency and getting it pinned and my environment and what dependencies do I have. And for that, I actually don't really like Jupyter very much. I like something more like VS Code. I think in that case, really you're writing software, and it's like basically an exploratory sort of like interactive development workflow versus a sort of like more traditional software development workflow, in my opinion. And um, I think it's hard to know when a project should transition from one to the other in my experience, but I think it is important that those be somewhat different.
Yeah, I think that's a really important point. I almost, it's not so much Jupyter Hub. I really like Jupyter Hub as a development platform, but when I have software that I want to actually deploy, it is not in notebooks. Like notebooks are just something, that I'm playing around with in the very small occasion that I write any software, which doesn't even really happen very often. But when it does, I do really like the notebooks. But yeah, definitely, when I want proper version controlled and version numbers, git commits, all that kind of thing. But one thing that I've really found with this kind of idea of like creating like the life cycle of a data science environment, or in particular for me, because I've been working with a lot of biotech startups, and I've been seeing them all kind of go from sort of this ground level where usually they're developing some kind of research, some kind of analysis. Sometimes they're collecting data, and sometimes they're getting data in from somebody else. So then they need this kind of environment that's, like you said, just throw the kitchen sink at me, like just give it to me, and I just want to be able to analyze my data. And then there tends to be this really kind of difficult transition to, okay, we have our analyses and now we need to deploy them, which is, very aptly the data science deployed podcast, right? So one thing that I found is that I kind of borrowed a lot of the workflow from Pangeo, and that's putting it quite nicely. I just went and install it all. So what I did was I created like essentially this really large build matrix of different bioinformatics Docker images, and they're all built on top of using Jupyter Hub, using RStudio, using just a ton of other kind of data science packages that you want, scikit-learn, HDF5, Xarray, Dask, Dask Gateway, all these kind of things. And what I found was that was really helping people out, because they were getting that sort of base environment that they needed, and then they could use that to develop. And then when they also got to the point where they wanted to deploy their code into production, which most often for me looks like having a Docker image and then running an analysis with that on AWS batch, we were actually able to just use the same Docker image that they were already building on, that had their whole development stack and is pretty well pinned for versions and things like that, and then also add whatever software, like whatever custom software they built on top of that, build that, push it to, either Docker Hub or, the AWS ECR, and then they were very easily able to go and do that and use that also for their production workflows. So I'm really liking it for that kind of environment, because I'm always trying to find a way to make that, less painful, that transition of I'm here developing and then I'm over here and I have production code or analyses that should just run on demand. So yeah, what are your guys' thoughts on that? Is using it for part of that kind of life cycle?
I think that's a great point, and I really like that example, because I think there's an alternative pattern I've seen. Like basically, I think what you're describing is the sort of domain expert or the scientist is writing this code, and then they can put it in the Docker image, that this like base image that you provide, and then you can deploy that thing. I think that's really nice, because an alternative sometimes that I have seen is scientist, domain expert writes a bunch of code, writes an algorithm, and then hands it over to an engineer who is responsible for packaging up. And I think I just have not seen that handoff over the wall work very well. And maybe the trade-off is your base image is a little beefier than it needs to be. It's not pristine code, but I think like there's a huge win in not making that sort of like switch between people. Like let one person be the domain expert, be the sort of like algorithm person, and then let them also deploy it if at all possible. So I think it's a great use case for Docker images, for these like great base images, these like great scientific computing libraries.
Another thing on that same note, I'm not too familiar with it, but I know it's kind of an example of sort of accommodating the workflow of a domain expert scientist and trying to productionize it, is the Papermill project, where you have Jupyter notebooks, and you kind of add the sugar to parameterize them, so that so it's like Netflix, for example, like has people write Jupyter notebooks, and they kind of run these notebooks in production in ways that are more like programs, because they have these special parameter cells at the top to run them reproducibly. But basically, you don't, as Ben mentioned, you don't have to have someone like port the notebook to like, real code or whatever, because I think, yeah, scientists certainly appreciate the the narrative flow of a notebook, the literate programming that it offers, the exposition, and yeah, people are following up with it. Like I'm on this I'm using this data orchestration project right now called Dagster that has this module called Dagstermill, which will orchestrate the Papermill notebooks. And so there's this kind of recognition that, like, people just really like their notebooks, and maybe it's less friction to like kind of gussy them up and make them a bit more production ready, parameterize them and such, and use them directly rather than sort of the traditional code modules. And I think that's sort of a similar approach of like, well, they have something that works. Let's see if we can wrap around it. Like just include that in the Docker image, or like include that in this Papermill pipeline, and work with that rather than kind of doing a wholesale rewrite or translation. So I think that's
really interesting. I'm curious what you think. What's your opinion on that? Like, is that a good thing? Like, should we encourage people to just write Jupyter notebooks and parameterize them and deploy the notebook, or is there a balance there where actually there is value in creating modules and functions and tests, and we should encourage the scientists to do that piece of it? I guess I'm a little bit contradicting myself, because I think I just said, like, it's great to let the scientists write the code and deploy that thing directly. I think for me, deploying notebooks crosses the line where it's like all of a sudden we're just encouraging bad habits. I don't know. I'm curious for your take.
Yeah, I mean, my take on that is I think there's an opportunity for the support staff, so to speak, the data engineers, to be able to abstract things out. I think a lot of times the domain scientists, they're more focused on their problem, and they kind of want to write the notebook that has their thing. And if they don't have to rewrite stuff, they'd love to import modules and do that. But I can imagine it possibly working where you have a bunch of people writing their own notebooks, and maybe a lot of them are doing duplicate work, and a lot of it's kind of messy. But then, the data engineering team can then look at that and be like, oh, I think I can abstract, because they have a mind for and I'm training for abstraction. I can factor out a lot of these things that are common into libraries. And so now I can encourage the domain scientists to actually import these libraries when they write their notebooks. So kind of the domain scientists don't have the double load of like writing and abstracting.
That's interesting. Yeah.
That's a theory that could work.
Yeah, I really like that, because I found that's such a huge hurdle for scientists as they're getting started out is, for us, it's like, oh, just write a function. But, you forget how difficult it is when you're first starting out, just these little things that trip you up, like, you didn't put quotation marks around something, or you miss a semicolon, or you mess up your white space, or, just, like all these little things that at some point we've kind of worked through, but the scientists really haven't. And I'm always really in two minds with whether or not, like, they should even have to, because they're already busy. They have their own stuff going on. They already have a lot of things that they have to know. They have like already kind of a lot of knowledge to keep up with. How much can we really expect for any one person to kind of cram into their head? I don't know. I suppose I have very mixed feelings about the whole kind of everybody trying to make the notebooks and things happen as code. I'm not totally convinced that that's gonna happen, but I think it's I guess anything that we can do to move more in that direction is great. And I love this idea of literate code and using it really for kind of communication and presentation purposes. I think that's such a valuable skill set. That's something like I always go and try to hammer at my students is, like, this is one of the most important things that you can do for any project that you have, is to create, whatever you're using, the R Markdown or the Jupyter book or Sphinx or something like that, that really goes through the steps and explains not so much the code, but how you actually thought through this problem. And, you can take those and you can deploy those for free on, like GitHub pages, or, read the docs or these other places and things like that. And so I also think that's really valuable for people in their own careers as well.
Jillian, I'd like you to speak a little bit more about, you're a little bit more familiar with the Pangeo project than me. Like what are some things that you think are, we're just talking about abstraction essentially of different people's, specific scientific workflows and what you can take away from that. So obviously you're seeing something like, well, this is very nicely, for geoscientists, but I see some great stuff for bioinformaticians here and more generalizable stuff. So like, what are the things that you sort of really liked in taking away the product, from the project that you think, is useful in your community and in other people's communities as well that they can take away?
So I really like the level of abstraction that they implemented. We're talking about the scientists and trying to, hammer them with levels of abstraction. So if you can actually go look on their GitHub repo, and they have one, I think it's just called Pangeo Docker images. I'll make sure to link it. And you can see they have like a base notebook that's just really bare bones. It's Jupyter Lab and Dask and the Dask Gateway extension, which allows you to start like Dask clusters on Kubernetes, which is a really, really neat extension. And I go throw it at my scientists all the time because I think it's like a really good framework. And because so much of the time, really, I'm just parallelizing for loops anyways. So it's nice to be able to hand that off to the scientists as a superpower that they can have. So I think at its base, it has Jupyter Lab, Dask, and then also at least a few scientific frameworks, maybe different file types. I think like HDF5 and maybe S3FS and a couple of these. So the base notebook is just really, really bare bones. But I think it was really important that they did that, because when I went and I looked at that, I was like, oh, so I see this is really for, I think, geologists and climatologists, but I'm really seeing how I can take this and adapt this to bioinformatics as well. So I actually went and just took that base notebook that they had and, grabbed the configuration, grabbed the environment.yaml, and even like, really heavily borrowed from their Docker build files and things like that. And then I went and I talked to a bunch of scientists, and I was like, hey, if I could set you up a platform for, like single cell analysis, which is a kind of analysis that is like really popular right now in bioinformatics, what packages would you want? Like, and they were able to immediately just like run off this list of like, well, I want this, 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 and this. And I'm like, all right, what kind of trouble have you run into installing these things? And it's like, oh, well, this thing needs this version of R and this, and so I was able to just go out and kind of canvas them. And, I got other people to do like all my work for me for that. That was fantastic. So I really like the way that it's organized for that, and how they have these different notebooks that are built into different Docker containers. And each one is really suited for the scientists. It's really for a different analysis type. So I have a whole stack now, and it has cell painting for high content screening, single cell analysis, like I just discussed, kind of a base machine learning library, but like with some of the kind of bioinformatics packages that are there. I'm going to put up a clinical genomics one pretty soon. All these kind of things. And, they're the kind of problems that I found myself solving over and over and over again, because I did, my kind of earlier career was very much support staff, was supporting the scientists and going and installing software on the HPC. So, I would have different groups coming to me, who were all doing the same, or mostly the same types of analysis. And so I would be installing these same things over and over and over again. And just kind of, over time, it's like, well, what can we do about this? There must be a better way. And so I like this. To me, this is my better way. I have been like building these Docker images for a while and throwing them out there. And then it's nice too, because I'm able to go back to clients and be like, hey, you need a Docker image for, for single cell or for high content screening or anything like that. And then, go and set them up. Usually on a Kubernetes cluster, sometimes on HPC. It depends kind of where they're at in terms of, like their startup life cycle. And they just have these pre-configured containers that are just, there for them. And then it's also been really important on getting a lot of the scientists getting into production with, I would say most of those are containerized these days. AWS batch is like, that's a requirement, is you have to have a Docker container in there. It's like, it's part of the workflow definition. So then I was able to write up just like some little like wrapper libraries, in particular around AWS batch, where they're able to actually go from their Jupyter notebooks, and we have like a couple pre-configured ones now. We're like, okay, here's a notebook for doing single cell analysis, and here's the Docker container that it runs on, and it's set up for you on Kubernetes, and here's how you start to submit it to batch, and here's how like you pull from your S3 and all that kind of workflow. So I'm just really liking it for the whole life cycle.
I have a question about that last piece. So I'm a scientist. I write my analysis in a Jupyter notebook, hosted on a Kubernetes cluster. I want that to run in batch. Do I actually translate that code? Do I port it to a script and build that Docker image, or is there some other thing that's automatically doing that work for me to sort of like push my Docker image and then deploy that to batch?
It depends, which I know is everybody's favorite answer. But yeah, it really just does depend. A lot of the tools in bioinformatics are these CLI programs, which is, another point we can touch on pretty soon in terms of like me and the way that I think the world should be. But a lot of times you're not really writing so much code, you're stringing together different bash commands in a particular order, and then maybe doing some QC or generating some plots. But a lot of analysis types really are just stringing together these command line applications, and then sometimes at the end, you're taking something and sticking it in a database or some other kind of data munging. For those, a lot of times they can just use the Docker image. So for example, with cell painting, there's a tool called Cell Profiler that is really popular in the space, and most of that is exposed as a CLI. But because it's also a Python package, when the scientists do need to get like really deep into something, they are able to call those different functions from the notebook and actually be able to go, and this is like a computer vision problem. So go look at the images, look at the measurements, see the data that comes out from there. So yeah, it depends. Sometimes they have more involved code and they'll actually write like one or more software packages. And then generally we just use the image that they were already on as a base. So like in Docker, you can use like base images to build off of. So we'll use that image that they were on as the base and then just install the Python or the R package and then throw that in, GitHub Actions or on the AWS code commit side. And then they'll use batch for that. And then they'll call that Docker container rather in their batch.
Following on with what Ben said about the interactiveness, I definitely see a lot of demand for that kind of thing where you kind of are working in an interactive environment like a Jupyter notebook, but you're actually able to set off production processes. I find myself, I think I was talking with Jillian a bit earlier about this. A lot of my personal development workflow on my laptop is I'll have a Jupyter notebook running, and that will connect to various Docker services that I have running, like a Docker Compose stack in the background that I'll connect through the Jupyter notebook. So it really doesn't matter so much that the Jupyter notebook is on local host, and that the Docker files are on local host. I'm just sort of interactively working with things, but they are containerized and they're kind of different services. And I see a lot of scientists interested in that sort of thing. I know at the National Energy Research Supercomputing Center in Berkeley, I have some colleagues who are working on that particular project about connecting people on a Jupyter hub to be able to submit things through the HPC system directly from Jupyter hub cells, rather than having to SSH in and submit shell scripts. So I definitely see that sort of a hybrid model where it's almost like the Jupyter notebook is kind of a more fancy web UI for your production system.
Alternative to just running a bunch of bash commands on your terminal.
Right, and you have more flexibility than just typing in text boxes and selecting drop downs and clicking buttons, because you can write and execute arbitrary Python code on a sandbox kernel, but you're still it's an interface to the actual system that you're running, which seems interesting.
Yeah, I think that is an interesting hybrid pattern. I've definitely seen that too. I think SageMaker has a nice Python SDK, and they really encourage that type of behavior. So you import your SageMaker SDK, and then you can launch a training job, which spins up a bunch of instances and runs a machine learning training, or you can use that to spin up a new Jupyter notebook instance or to deploy an endpoint. I think that is pretty interesting. I think I like that better personally than the just parameterized notebooks everywhere. But I think it's still not necessarily, or it doesn't necessarily encourage it to be reproducible. So I think ideally that chain of commands is version controlled somewhere. And I think at different stages, there are different requirements. Early on, I don't think it really matters very much. You're just sort of like trying to get a feel for it. You're trying to like kind of play with your system, your algorithm, your data. But I think at some point, depending on the context, I come from the world where we're building production software that needs to run at scale for thousands of users, and so I'm scared of something that's not reproducible. Like I want it to be version controlled. I want it to be very predictable. I could definitely see that that's not a requirement in all cases, but yeah, I definitely like the hybrid approach more, I think.
Well, that's another thing that I really like about this setup is that you can use, like these Docker images. They're all under versioning, or at least, the ones that I build and the ones that Pangeo builds. And I think there are a few other communities that are kind of picking up on, like the same sort of build stack. So those are under version control. And then say I want to take an analysis to kind of, I want to take it a bit further. I can use that image as a base image and then build software on top of that and then deploy that Docker image. But say that's like one type of analysis. Say that's, I don't know what this particular type of single cell analysis that I'm doing, that could be in a repo, and then all of that is versioned, or at least all the code is versioned. I don't know what you do about versioning data. And you can keep on building those out. And then, and I like that kind of it's very like stepwise, because then once you have that, if you have the image and you have the software and you have the pipeline and you have the business logic, then I think it's much easier to go and either have the scientists build out the production workflows or get a data engineer to do it and hand them something, like you were saying, Dagster. I like Airflow over here. Or, I know some people are jumping on the Prefect bandwagon lately. But I think if you have those steps already in place and you're already kind of containerized and you understand what the logic is, moving to that next level, I think is much easier than having the scientists take care of the software stack completely by themselves from scratch, because I've had that go wrong so many times.
I want to echo what you said, Ben, about transitioning from exploration to reproducibility, and often I find that I don't know when I'm ready to transition, and it's maybe already too late. So it's like one thing I appreciate is, for example, when I'm in a terminal, I use a bash shell, and often I'm just kind of playing around, and I discover something that's nice, and then I just type in history once I figure something out, and I can see how did I get here? Because that was good, and let me reconstruct that, and I can see the history, the provenance of how I got to where I was, and maybe I can actually develop a reproducible procedure from a certain subset of those steps. Whereas often I don't know where to go with like a Jupyter notebook if I'm like executing this cell, this cell, and this cell, and it's like, okay, this is good, but now
I do that.
Now I need to mentally reconstruct from memory. I can't just look at a log. Maybe there is, but like it's not as like intuitive to me as like history, like just sort of built in, like how did I get here, so that I can then switch into productionizing mode from the exploration with this guide, and not just from my memory. And yeah, because it could be messy, but it's nice to have that kind of written record to analyze. And another thing I was thinking about when you talked about, Jillian, with being able to build on Docker images, and this is a bit about what Greg Wilson mentioned the other week about kind of, you felt like a lot of times Docker images can be kind of opaque in some sense, they're not necessarily reproducible. And I've heard of people talking about for data analysts having these giant SQL queries that grow over time, and they kind of get inherited, and people don't really understand what they're doing, but it's kind of, this SQL query will generate this report, and it's maybe pages long and something. And so I can imagine a situation where you kind of have these giant inherited Docker files that it needs all this stuff, but I don't really know what all these packages do, but I'm afraid to get rid of them. And so it's still, it's reproducible, but it's not clear that it's sustainable or that it's, I don't know. I don't know how to get around that. Yeah. And if you
I think that's a great point. I think that's the sort of trade-off of asking And in my experience, I don't know if you all agree with this, but that's the trade-off of asking scientists to go all the way to building production is like, a lot of times they're not necessarily gonna have a sense of like what's important in this Docker image, and it's like I've got this black box, this sort of like voodoo magic, this incantation that I make, and then it just works in the production system, as opposed to like really understanding each piece and like what do I need in here and what do I not need in there. I've definitely had the experience with the giant SQL commands. I think I agree. The same thing can happen with massive Docker images. Yeah, I don't know a good solution to that necessarily, except if you understand how all the pieces fit together, then you can start to strip out stuff that you don't need. Um,
Yeah, I can definitely see how that would be a really big problem. I mean, I've been on multiple systems where it's like, I don't know why this works, but it works, so nobody's allowed to touch it, and we just kind of stay in that, in that framework for like years and years, and then, eventually you have to retire the server or do some, eventually you do have to upgrade, and somebody needs to understand it, and that can cause a problem. I don't really have any great ideas for fixing it. Just, I don't know, maybe have some kind of policy where you don't inherit from more than X number of images, or uh, some that have, like daily builds, or, we were talking about writing tests and sort of the kind of pitfalls with that in terms of like, well, you test whatever is easiest to test, not what is necessarily the most important. So yeah, I think it's a really tricky problem. I don't think it's very well solved, and I definitely kind of hear the opinion of people who are just like, just throwing the kitchen sink in a Docker image is not like fixing the problem. There's something like fundamentally very broken here. But it's also the best that I've got for now. So, that's just kind of where we're at.
Do either of you have any thoughts on kind of the lineage or provenance chain, something similar to Bash history for interactive stuff, and especially something that someone can understand in order to reproduce, ideally a domain specialist, but just where someone's exploring and then they can like review what they've done in a principled way to reconstruct it. Any kind of technological tools that help with that.
your trick of just looking at your bash history is probably the best one I've heard of. I think that's a great life hack. I was thinking like Jupyter notebooks do have checkpoints, but it's really not. It's not what you're looking for in that case. I think it's not really a history of the chain of commands that were executed. Um, yeah, I don't think I have a good solution to that. I think I know Jupyter the Jupyter server does do some logging, but it's not really logging each command. Um, maybe that's a Python package that needs to exist. So it's just like a history of every command you ran in your Jupyter notebook. Um,
I think Prefect is actually doing the best job that I've seen out of that with various kind of workflow runners. And I guess Nextflow too. Nextflow does a really good job of that. But Prefect kind of has this sort of like idea built into it that you're not, that the data scientist is not necessarily paying attention to what they're doing, and they could be like, like this bash history kind of thing. Oh, 20 rounds ago, this workflow worked and I liked what it did here, so I kind of want to go back and look at that. And it seems like they at least have that sort of built into the workflow a bit. I haven't really used it and tackled it enough to know kind of how robust it is, or, like in my case, like how idiot proof it is, like how much can I hammer on it without really breaking it and things like that. But it does seem like people are at least aware of that being a problem and are trying to, like find ways to be like, okay, how can we transparently, without having to do, say, git commit or something like that, like without the user explicitly saying, save it here, or, release a version here or something like that. It's just transparently done every single solitary time you run this prefect. I forget if they call it DAG or tasks or exactly how they do that. But, every time you run this, you get, essentially like kind of like a hash that says this is what you ran and this is when you ran it. And it like automatically versions all your workflows and things like that. I don't know. I don't have a great answer for that. I'm pretty good with like the bash history that I'll just stick it in a make file. And that's kind of, and I even put on all my GitHub projects, like, the make file is the place to always look. It's always like more up to date than anything else. I've been trying to get into a better habit of actually writing like tests as I go along for these kind of things, because there's always like all kinds of assumed knowledge that I've tested out in a notebook or just in like an IPython console or something like that. And I should be writing it as tests. And I don't always do that. So I'm trying to get better.
You're the only one who doesn't always do that.
I know it's only me.
Yeah. I do think Git does solve that problem. So I like that's where I think there's a certain stage where you need to be able to go back in time and reproduce. And like maybe ideal state is we encourage people to use Git, idiomatically.
But Git tracks the code. It doesn't track, like if you're a data scientist running like a specific workflow, it doesn't track the way that workflow ran. So
But
yeah,
then
I hear you in terms of like versioning software and stuff, but I'm not sure that it fixes everything.
I agree, but I think there are pretty good ways to version the chain of commands as well. So I think, DVC actually is an example of one that will encode your DAG as a text file, and then you can commit that. But actually, like make you can actually encode your DAG in make as well. So like each command is a command, and it's got a history of commands that it depends on. Or I think another pattern that I've used is you actually program the commands in Python. So, and then those like commands are what you version control. So you've got a train model command, and you actually call train model from your Python package. It's a little clunky, and it slows you down if you're trying to explore, but I think that does allow you to go back in time and see what exactly did I run to get to this state.
Yeah, I do. I like that myself. Like I've been kind of hammering, like when I work with people lately, you want to have what you're doing exposed as functions, so have it exposed as an API, and then throw like some kind of CLI, on top of those functions as well, so that you're able to run it from, kind of like from both angles.
So that's a hack. Then you can piggyback off of Bash history, because all your stuff is commands now.
Because it's both, right? Yeah, exactly. And you can get the nice help menus, and you can get like some nice checking too, like make sure this file exists, and if it doesn't, it will automatically fail, because that's something that always gets me. I'll be like in a different directory and not be paying attention, and then and then the file doesn't exist and stuff like that.
I guess one thing that's nice about the Bash history, but you brought this up, Jillian, which is good too, is because the Bash history doesn't cover everything, because there's a lot of hidden state. But what's nice about it is a lot of times it's very declarative. So like what you'll type on the command line is like the thing and its inputs and its outputs. It's very functional, but what it's operating on sort of changes over time. Like the underlying data files might have been mutated, and so it doesn't sort of solve this versioning problem where like maybe you're interested in under the hood, this was run, but it was run on this file when this file had this SHA-256 hash or whatever, and that's an issue. But one thing I was just thinking of was back to our conversation with Greg last week. He mentioned the importance of logging, and he wanted people to do logging, and I was thinking that might be an appropriate keyword here that came to mind, where you're kind of like running a program, and wouldn't it be nice to kind of have very verbose logging, where you're not necessarily inserting manual print statements, or you're not necessarily inserting manual logging commands, but there's sort of a lot that's derived from the things that you're running, or you're able just to have a log of like, well, this function ran with these arguments, and this was the output, and this is the type of it, and when it opened this file, this was the SHA-256 hash of the file, and blah blah blah. Just very, very verbose logging, and being able to tune that. And there's certainly work on logging for scientific workflows. There's the Elliott project by Itamar Turner-Trauring. There's struct log, and there are various things that help with logging. And there's like the default logging library in Python. And what's nice about that is again, you can kind of leave things in there and like set the debug flag on or off, so you kind of you don't have to hammer down your program performance and turn things off. But I think getting better at logging would probably go a long way towards that. But also being able to make it understandable. I'm sure we've all like looked at, like I do web development, and it's nice to have actual monitoring instead of having to like grep your Apache or Nginx logs. you know, because everything's there, but like, you know, to reconstruct what actually happened. But it's nice that it's there, you know. But I mentioned structured logging approaches would help a lot for data scientists.
Yeah, well, that's what I really like about Airflow. Like whenever I get kind of, people and they want some kind of like productionized data analysis, I pretty much, one of my kind of, my line in the sand is I'm like, no, it has to have logging and it has to persist, because not all of these ideals will persist the logging, but if you're using something that's at least backed by a database like Airflow Prefect, I don't know what other solutions specifically have it backed by a database, but you always have those there. And so you can go through and you can do auditing, and you can do, you can even configure things like SLAs, and you can throw a bunch of stuff in there, and you can, then you can start to get into these other kind of states as well, where what can go wrong will go wrong. Like if something goes wrong, alert me on Slack or raise a ticket in Jira or email somebody or something like this too, where you're starting to deal with actually sort of the state of things as they will be, which is kind of another interesting point. But yeah, log everything all the time. Be a digital hoarder.
Okay. Do either of you have any last thoughts? We can wrap it up.
Well, I want to thank Jillian for pointing me to the Pangeo project and pointing us to that, and having that be kind of the framework for this episode. I think there's just a lot there, and it really highlights. I think that project highlights a lot of different components to serving and making something successful. There's sort of, I really like that there's kind of a guide for scientists, and there's also a technical architecture and deployment guide. I like how things build on each other. Sort of, you can sort of take what you need and build on top of that. Like Jillian mentioned, you're able to take like a base Docker image, and build off of that. And the geoscientists will do more than that. And having their discourse forum and things like that. I think that community aspect is really important. So I just being able to do that and just that it focuses on a niche, and it's so big. I think that's one of my big takeaway for me, is that there's a lot even in the very small, or what you perceive as small, and yeah, that's what I took away from that.
Yeah, I thought they did such a good job. It's really, I've been following it for like, I guess, a couple of years now, and it's really inspiring how they really went through all the stages, and they really focused a lot on community building and this idea of, nobody should be sitting in their corners building everything from scratch. Let's, get together and solve some of these problems on, on like multiple levels. So it's cool. I think like it seems like they're kind of heading in some new directions and doing some neat things. So I don't know. It looks like an interesting project anyways to keep following.
Very cool. Well, that's all we have this week. Thanks again for all your time. Thanks again for introducing us to the Pangeo project, Jillian. And we'll see you all next week.
Bye.
All right. Bye-bye, everybody.